In this situation, we are looking at this system of linear equations where we have a variable for one of our parameters here. So it's not just solving the system. So what we want to do is we want to consider what happens for different values of k. So what values of k give me exactly one solution, and what values of k give me either no solution or infinitely many solutions. So to begin with, this is kind of in a form that I don't really like. So let's move it so that it's in the ax plus by equals c form. So over here, this becomes 2x minus ky equals 4. This one becomes 4x minus 10y equals, move that to the other side, equals a positive 8. Okay, and now I can find the slope of each of these. So if I were to take the first one, 2x minus ky equals 4, to find the slope or the gradient, I'm sorry, you can't see that side. Okay, there's that for now. Okay, I want to solve for y. So I have negative ky equals negative 2x plus 4 divided by negative k. So y would equal 2 over k x, and then I don't really care about the rest of it, to be honest, because all I care about, this negative divided by negative is a positive, all I care about is the gradient. Okay, and then the other one, 4x minus 10y equals 8, negative 10y equals negative 4x plus 8 divided by negative 10. Y is equal to 4 over 10 becomes 2/5 x. And once again, I don't care about the rest of that. I do care, actually. Let me change that. This would be plus a negative, I lied. It would be minus 4 over k. And this one would be, we divide here. That becomes a minus 8 over 10 reduces to 4/5. Okay, so here's our slope, here's our y-intercept. Here's our slope, here's our y-intercept. And notice that in both of these, if k equals 5, we have the exact same line. Okay, so when k equals 5, there are infinitely many solutions. Now, back in Algebra 1 or Algebra 2, you could have stopped here, and just said there are infinitely many solutions and you'd move on with your life. As we move forward in IB, especially in HL, we're going to know, well, what are those infinitely many solutions? Well, they are the line y equals 2/5 x minus 4/5. So it's all the points on that line that make up that solution. And this seems kind of silly at this point, but once you get into 3 dimensions, HL in particular, it'll make more sense what we're talking about. So then they say, okay, well, what happens when k is not 5? When k is not equal to 5, we want to solve that system. So I'm going to grab the system from up here. 2x, oh, you can't see it. I'll try again. 2x minus ky equals 4, and then 4x minus 10y equals 8. So I go to solve that. I notice that I can use elimination. Here's my system. I can use elimination if I multiply the top equation by negative 2. Okay, so coming through here, I could multiply this whole thing by negative 2. So that gives me now the equation negative 4x plus 2ky equals negative 8. And then I still have 4x minus 10y equals 8. I'm sorry, I should have made this easier to see the whole thing. Okay, so that's that. Now notice when I go to add things up, this is gone. This becomes 2ky minus 10y is equal to 0. Well, they're asking me to solve for y. I need to figure out what that y value would be. Well, when I can factor it out, 2k minus 10 is equal to 0. If I want, so y is getting multiplied by all of this. To solve for y itself, I need to divide. But I have 0 divided by anything is still just going to be equal to 0. So my y value here is equal to 0. I saw that earlier. I worked through this problem and I got a little confused. So let's finish with this thought and then come back to see what that means for us. So I can take this and I can plug it in to one of those two equations. So if I have 2x minus k times the y value, oh, you can't see it, I'm so sorry. The y value was 0, and this is equal to 4. Well, anything times 0 is still 0, so now I have 2x is equal to 4, therefore x is equal to 2. So what I'm finding here is that these two lines, even when k is not equal to 5, these two lines intersect at the point 2, 0. So I solved it, and then I got confused. So I went to my handy-dandy Desmos. Hang on just a second. My screen looks funny, so let me fix that. Okay, I went to Desmos, and, okay, hang on, this is going to become a little less polished, but here we go. Okay, so I went to Desmos, there we go, and I created a slider in this situation here. So what I did is this first line here, I have 2x minus ky equals 4, and then I let Desmos change the value of that k, and then the other equation was 4x minus 10y equals 8. Well, notice what's happening there. As it changes, they always have that point of intersection at 2, 0. So notice if I come over here and I stop this, or I can just tell it, I want to know what happens when k equals 5. Okay, then notice this line right there, those two lines are exactly the same. So I can turn this off and then turn it back on. See how that's red? It's graphing this one where k is equal to 5. And then I can turn this back on, and then the green kind of overpowered the red. So they're exactly the same line. So notice, and this confirms what we said a minute ago, was when k equals 5, there are infinite many solutions, and those solutions are that line. And then when k changes, when k is not equal to 5, they still just intersect at that particular point. All right, go practice some systems. Make sure that you're really good with solving systems of equations of different types, and play around with some of the, like this idea kind of goes beyond what you may have seen in Algebra 1 or Algebra 2. Good luck.